5:30, so we'll begin. This talk will be on building and debugging Microsoft Transaction Server components with Visual Basic 6.0. In particular, I will concentrate on creating three-tier architecture web applications. If we look at the agenda for the talk, I'll start by introducing the sample, since snippets of code from the sample are used throughout the presentation. I'll then go into the advantages and disadvantages of two-tier versus three-tier architectures and discuss when you would use each one. I'll then introduce MTS and show what it's used for. I'll go into server component design and in particular discuss stateful versus stateless objects. I'll then go into more detail into the transaction server object model and its runtime services. I'll discuss server components options in Visual Basic, in particular options that will help improve the performance of the applications. Finally, I'll discuss debugging MTS components in both Visual Basic 6.0 and Visual C++. For the sample web application, I chose an online stockbroker. I believe this has the common denominator of requirements for any internet application. It has to be reliable because customers are not going to like it if the application goes down while they're making trades. It has to be fast because day traders want to obtain a trade at the latest real-time quote. It has to be secure. Customers don't want others prying into their accounts. It has to support transactions. By its very nature, you're debiting from cash and adding to equity holdings or vice versa. It has to support concurrency. At any given time, multiple clients will be online. Finally, it has to be scalable. As the number of customers grow, you want it to remain reliable and remain fast. As you throw money at the project, introduce quad processors, or buy more database connections, you want to be able to support more customers. So let's look at two-tier versus three-tier architectures. The advantages of two-tier are that it's easy to develop and employs object-oriented programming techniques. The default project in Visual Basic is a standard exe. It almost encourages you to weave the business logic into the client's application. The problems are that at the end of the day, you end up with a large client application. It may take a considerable machine to run this relatively large client app. You may have limited scalability. In particular, if the client application holds a reference to the server component and the server component perhaps has a reference to a limited server resource, such as a database connection object, then as the number of clients grow, eventually the limited server resources run out. Maintenance is difficult because the correct software drivers, the ODBC drivers, etc., have to be installed on the client machine. Whenever you make a bug fix, you have to redistribute the client to all the client machines. I know you've seen this slide before, but this is the alternative. HTML front end can represent a thin client, ranging up to a rich Windows client application. These talk to some COM components in the business logic layer. The presentation will really focus on COM components running in the Microsoft Transaction Server runtime environment. The COM components persist data out to the database or to files on the third tier level. So the characteristics of three-tier are that it will be more scalable, providing the components are written well and correctly. It has an easy distribution for the clients, especially in the case of HTML front end. It has more administrative control. You're able to control security access, transaction control, various timeouts in the business tier layer. The disadvantages revolve around the fact that it's harder to develop. At all times, you have to be conscious of the usage of server resources, in particular, minimizing the time that the limited server resources, such as database connections, are in use. You also have to minimize the number of network round trips. Network round trips are a performance killer. We've taken the business logic, pulled it out of the client, and put it onto a server component. So more network round trips may be involved. So when would you use two-tier? Well, you could use it if it's a well-defined office environment, you know the number of users are not going to grow, the client machines are well-defined, it's easy for you to install the drivers, it's easy for you to install a bug fix to the client application, but you would want a three-tier design, particularly in an internet scenario. For the best scalability, you're hoping for more customers to come online. The minimum client maintenance, of course, setup can be a product support hit. So where does MTS fit into the picture? The COM components are going to reside in the business logic layer. They're going to run in the Microsoft Transaction Server runtime environment. COM components applying the presentation layer, writing data out to the third tier. Going into more detail for the online stockbroker application, I chose a HTML front end that talks to a web class, which is new to Visual Basic 6.0. The web class contains HTML templates. These templates can be modified on the server at runtime. Actually, I should say the HTML talks to an ASP page, which invokes objects in the web class. The web class then talks to objects running in the MTS environment, and the objects in the MTS environment do database work, in particular removing cache from the customer SQL Server database and adding to equity holdings in the stocks database, or vice versa. Looking at the application, just to show you, HTML front end, at the moment I've got 30,000 in cash and own 10 Microsoft shares. They're worth $100 each. I have a web class running in one instance of Visual Basic, and the other instance is the stockbroker component is shown running in another instance of the Visual Basic IDE, actually in the Microsoft Transaction Server context. I'm going to debit from my cash and add to the equity holdings. This should take the balance from 30,000 to 20,000 and add to equity holdings from 10 shares up to 110 shares, I think it was. It involves a transaction across two databases. We'll come back to that and debug into it. So what does Microsoft Transaction Server provide for these COM components? Well, I think it's divided into two groups: administration of the COM components, and then runtime services and programmable interfaces that can be used by the developer to also make business decisions. MTS administration is done through MTS Explorer, which I'll show in a second. The runtime services include management of threads. There's a maximum number of threads that it will reach, and it will try and be intelligent to give you the best performance. You're now able to set the maximum number of threads in the registry, though. Management of object lifetime, especially through activate and deactivate that I'll discuss later, and actually tearing down objects, etc. Also, programmable interfaces like object context, object control, transaction context, a variety of interfaces in the Microsoft Transaction Server pipeline that I'll discuss. Looking at MTS Explorer, we can control the security access to components, the transaction behavior of the COM components, various timeouts, including transaction and activation timeouts, process isolation, the ability to take the risky interfaces and move them off into their own process, or, for better performance, have the interfaces run as part of the process of the client. I'll show MTS Explorer. This is installed with NT Option Pack 4.0. On the highest level, we see the transaction statistics, which I mentioned earlier, where the administrator is able to see how many transactions have been committed or aborted, the amount of time the transactions are taking, so the administrator is able to see if something is wrong on the business tier level. Going up to some properties for the computer, we're able to set transaction timeout. Here I've got it on a high number for debugging purposes. And drilling down, packages are logical groups of components, and If we look at the properties for the package, here I can decide library package versus server package. If I choose server package, the components, when they're instantiated, will be instantiated in a separate process, so they're isolated from the other components. I'm even able to take interfaces from one DLL and put them into a different package than other interfaces, so I could put the risky interfaces into a separate process. Drilling down still further, we can see the interfaces, and you can see the methods of the interfaces. Here I see the 7, I think if this derives from iDispatch, yeah, it looks like it does. We see the iDispatch methods and a number of other custom methods in the interface. I'll talk some more about some of the other options in MTS Explorer. So hopefully at this time you're interested in the three-tier architecture. Now, just because it's a three-tier architecture does not mean it will be scalable. The components have to be designed well. What do I mean by stateful versus stateless objects? Well, a stateful object is going to have members to the class, or perhaps the object uses global variables. Here I have some property procedures, and we're filling in the members. Once the state of the object is well defined, we execute a method that's going to perform a unit of work. A stateless object, in contrast, takes all the information it needs to perform a unit of work as parameters to the method. What are the disadvantages and advantages? Well, when we pull the business logic out of the client onto the server, and a client starts using a stateful object, a rich object that has lots of properties and methods, every property access is going to involve a network round trip. Network round trips are performance killers. The transaction will be in progress for longer, and while the transaction is in progress, database locks are in place, so other clients are unable to access the SQL Server page of data. Also, the valuable limited server resource of a database connection object is in use for longer. It's not available for other clients. So an argument in favor of the stateless component is to have one simple method that involves one network round trip. The transaction is in progress for the least amount of time, and we can release the database connection object to the pool for other clients to use. Now, not just database connections, what about objects themselves? In the stateless case, of course, we can recycle these objects. When one client logs off and another client logs on, the client logging on can get the object from the previous user. Because they're stateless, there's no problem about recycling them out to the new clients. In the stateful case, it's not clear what state the objects will be left in, so it's not clear that they can be recycled. Most likely, new objects would have to be instantiated. Eventually, the server is going to run out of memory if enough customers log on and are instantiating enough objects. So when would you use stateful or stateless objects? Use a stateful object as a local DLL server to a rich Windows client application. That's fine, there's no network round trips. Or perhaps as a helper server to a stateless component. If in the method of the component it instantiated the stateful object, filled out the properties and methods, and then released the reference, that would be fine also. But you would probably want to use stateless objects when the components are separated by a network to reduce network round trips. Also, if you want the objects to be part of an object pool. Finally, if you want all the work to be done in one method, the method represents one unit of work, an atomic transaction method. Now, even if you have stateless objects, you're probably going to need to share state between instantiations of the same type of object or between instantiations of different object types. How do you share data between the different objects? One way is to persist the data to a database or to a file on the third tier or even on the business tier layer. The problem with that is it will be slow. The benefit is it may be the most scalable. If you get the database connection, write out your data, and then release it, there's nothing hanging around on the server, at least in RAM or whatever, so it may be the most scalable. You could cache the data as client cookies, but that may not be the maximum reach scenario, because if they don't have cookies turned on in their browser, that's not going to be a possibility. For the best performance, of course, you would use non-durable server memory. If the server crashes, you lose that state information. But you have a couple choices here: Microsoft Transaction Server Shared Property Manager and the IIS object model for web applications. Looking at the Transaction Server Shared Property Group Manager, on the outer level we have a method to create a property group, and we can access those groups using the name that we gave the group in create. Then within the group we create properties. The properties have values. You can set them to variants or strings or whatever you want. This is a thread-safe way to store data. Here's a snippet of Visual Basic code that uses the Shared Property Manager. I instantiate the new Shared Property Group Manager. I then call create property group and give it a name associated with the customer who's currently logged on. The second parameter is called the isolation mode. It defines how the property is locked when it is accessed. Lock set get means lock the property for while the property is being written to. If I have one object that's writing to the property and another object that's reading, the one that's reading does not want to get an intermediate value that could happen if a thread context switch occurred while the write to the property was taking place. The alternative to this parameter is lock method. In lock method, the entire property group is locked until the method of the client, which in this case is an MTS COM component, has finished. You would do that when the properties only make sense when taken as a whole. So for example, here I have a property of the number of shares, 400, and the symbol for the shares that I bought is Microsoft. If later on I sell 300 Intel shares, then one object may change the first property to 300. It's about to write the second property to Intel when there's a thread context switch, and the other object would read 300 Microsoft, which would be wrong. So you would use lock method to lock the entire group until the method is finished, until it fills out all the properties with the group. The third parameter here is called the release mode. It defines when the property group is released. Process means tear down the group when the process is finished. You can also choose standard, which means release the group when the last reference to the property group has been released. An alternative to using the Transaction Server Shared Property Manager is the IIS object model. The application object stores data as a global. The most common example given to describe the application object is a web counter. If I want to count up all the clients who are hitting a particular page, I could increment an application object. In this case, perhaps I want to show the Dow Jones Industrial Average on every client's web page. The session object is per session of the client browser. So here I could store details about what the customer has been doing. Okay, so let's go into the MTS object model and services in more detail. But before that, I want to show how easy it is to create an MTS object in Visual Basic. People sometimes say, how does a Visual Basic component, MTS component, look any different from a regular component? It doesn't really look much different. In Visual Basic 6.0, there is an attribute here, MTS transaction mode, which I probably would want to set away from 0. This is new, and I'll describe this transaction mode later. I would then go to References, and reference Microsoft Transaction Server Type Live. I may or may not implement the object control interface. Oops. I'll probably put some custom public methods in here that are going to perform the various work required. I then will compile as usual. And import into MTS Explorer. When importing, you can choose to import it as a file or from the registry. I recommend using it as a file because then it will bring in the MTS transaction mode attribute. It isn't done if you choose the registry. Okay, so that's all there is to it. We bring it in MTS. Now when clients invoke the various public methods inside the component, it'll be running in the MTS environment, taking advantages of the services that I'm about to describe. If we look at the most common interface used in transaction server components, it's the object context interface. You will see a lot of calls to get object context, which is part of an app object inside the Microsoft Transaction Server type-like component. And off of get object context, we will call things like set complete, which indicates the transaction server that the work that went fine and the database writes can take place when the method has been exited. If you call set abort, it indicates to MTS that it needs to roll back any database writes. There are a variety of methods in here. One is in transaction to indicate whether we're currently in a transaction. Create instance is an interesting method. This will create a new instance of a common component similar to create object in Visual Basic. The difference being if you create instance of an MTS component, that created component will inherit the identity and the transaction context of the creator. So let's go into the transaction support for Microsoft Transaction Server. It offers transactions across databases. These databases can be on different servers. The only caveat is that the servers must be running the MSDTC service. It has either automatic or client-controlled transactions. In the case of automatic transactions, the transaction is begun by MTS before the method has even been entered in the server component. You then tell it by a set complete or set abort whether the work went well or badly, and MTS will commit or abort accordingly when the method is exited. In client-controlled transactions, the client gets to call the shots on when the transaction takes place. They're generally frowned upon because the client has to invoke the method and then invoke another method to abort or to commit the transaction. So that's two network round trips. They're also frowned upon because the server component is not considered as reusable. If I were to move the server component to another project, does the client know that it needs to commit or abort the transactions? So in this diagram, an example I've kind of cited before, a method which debits from cash in one database and is adding to equity holdings. Transaction server is going to help with the transactions here. What is that MTS transaction mode attribute in the classes in Visual Basic 6.0? Requires transaction means that the component must have a transaction going when the method is entered. Now, if it was created by a different MTS component, it will inherit the transaction context of the creator. If it was not created by an MTS component, then MTS will start a new transaction for it. Uses transaction means the component doesn't care. It will use the transaction from a creator if the creator is an MTS object, but MTS will not create a transaction for it. Of course, requires new transaction means that MTS always creates a new transaction when the methods of the component are entered, and no transactions mean the component does not take part in any transaction. So here's what a typical Visual Basic method in an MTS component looks like. We remove from the cache from the database and then attempt to buy, with that cache, attempt to buy some equities. If there's an error in the buy stock routine, we fall into the error handler, we call set abort, and MTS will abort the roll back the transactions when we exit the method. If the work went well, we call set complete. Now, some people feel that Microsoft Transaction Server was misnamed because it does not just offer transactions. It offers a variety of services. Just-in-time activation is another service I'm about to describe. Going forward, of course, MTS is integrated into COM+ and will offer a bunch of new services as well, such as dynamic load balancing, in-memory databases, etc. But going into just-in-time activation, there's a dilemma for a two-tier architecture where a client instantiates objects, perhaps it's a DCOM architecture, it instantiates objects on the server. The client could maintain the server reference throughout the lifetime of the client, but if the server object is holding on to limited resources, such as database connection objects, then it's not scalable. Eventually, we'll run out of these limited resources. The client could release the server reference between method calls to the server, and that would be more scalable, but now the client pays a large performance penalty because instantiation of the objects is difficult, particularly if the server component has to retrieve limited server resources. Just-in-time activation is meant to be a way out of that. Here the server component will be activated just before the method call, so it can pick up a limited server resource, and then it will be deactivated after the method call, providing that in the method it calls setComplete or setAbort, or if the transaction fails for some other reason, such as the database going down, or if the client releases the last reference to the server object. How do you get this activate and deactivate event? Well, you implement the object control interface, which I showed earlier. So perhaps in the activate event, I'll get hold of the database connection object, and then in deactivate, release it. There's a third function in this interface, can be pulled. It's recommended you, providing you can lose all your state in deactivate, or you have stateless components in the beginning, it's recommended that you return true to this function, and then going forward in new versions of MTS, it will be able to pull the objects. I'm going to just show you the event sequence that takes place then. The client instantiates a new server MTS component, so class initialize is called. Then when the client invokes a method, MTS calls activate, perhaps we pick up a database connection, etc. The method then executes, and then MTS calls deactivate for us. We can release these limited server resources. The same event sequence occurs again when the next method is called. Only when the client releases the reference does class terminate occur on the server. It's possible to avoid deactivation between method calls. You probably want to do it if you did have stateful components, because many property procedures are going to be called quickly in succession. To do that, you can just avoid calling setAbort or setComplete. More typically, you will also go a step further and call disableCommit to say the transaction server, this object does not possibly have enough state to commit the transaction, don't allow it to happen. We look at the event sequence for a method that does not call setComplete or setAbort. The client instantiates a new object. When it calls the first method, activate occurs. Now there's no deactivate. We didn't call setComplete or setAbort, so the next method comes right in. Only when the client releases the last reference does deactivate and class terminate then occur. So that was just-in-time activation. Another service is security. MTS allows you to control security access to your components in two ways. There's declarative security that the administrator can use with MTS Explorer, and then there's also programmatic security that the developer can put into the COM component. Each package runs under a different identity, so that when the components use SQL Server, it'll be as if the identity is logged on. Here, package 1 has an identity of administrator. In SQL Server, I would set permissions so that only an administrator is allowed to update the database. Similarly, I would set read-only permissions to the user, so the components in package 2 are only able to read from the database. Going back, we're able to extend security by limiting the people who are allowed to instantiate and invoke methods in the objects that are running in MTS. We do this by defining roles. Roles are lists of NT users and groups who are allowed to use the components. Here, package 1 has a role that only allows administrators to instantiate and invoke methods in the components. If I tried it and I wasn't an administrator, I'd get a permission denied in Visual Basic. Just showing where that is in MTS Explorer. Okay. It's at the package level. You notice roles here, and let me look at the system package, which has some roles defined. Here, administrators and some users, which are going to be a list of NT users, are allowed to use the components in the package. But in fact, I can go a step further and define roles down to the interface level. You can choose at these interfaces of which roles that are defined for the package are allowed to use this particular interface. Apparently only administrators are allowed to use this particular interface. There's also programmatic security, where the developer can make the decisions about who's allowed to do what inside these components. This is done by the security object, which is obtained from the object context interface. We can call getDirectCaller, getDirectCreator, original creator. If we look at the diagram, if a component in process A instantiates a component in process B, which in turn instantiates and invokes a method in component C, if C were to call getOriginalCreator, getOriginalCaller, it would come up with an answer of the identity of A, the direct creator and caller, the identity of B. Looking at a snippet of code here, if I obtain the security object, first I want to check if security is enabled. It will only be enabled if the component is running in a server package, not as a library package. Providing it's enabled, I check if Brian is in the name of the direct caller, and then I call the admin routine. So you would probably use this feature if you wanted to make a decision such as, if the order amount is less than $500, and if the person is an administrator, then go ahead and let the transaction occur. Otherwise, return an error. It's frowned upon, programmatic security is frowned upon by some because you're hard coding people who are able to use the components into the components. So of course, as people come and go from the organization or move around the organization, it may involve a recompilation of your component and a redistribution to the server. Another service that MTS offers, as I mentioned, is the thread pool manager. It will try and manage the threads to give the best performance. It uses the ODBC resource dispenser, which pulls the database connection objects. It's an object instance broker in the sense of it controls the lifetime of the objects by firing activate, deactivate, and also initialize and terminate. It does not currently pool objects. That's slated for COM+. So I've gone over the services that MTS offers. Hopefully you're interested in a 3-tier architecture. You're interested in using MTS in the middle tier. Now we'll go into some interesting server component options in Visual Basic 6.0. Unattended execution means that any message boxes or runtime errors or other modal dialogues that appear will in fact be written out to the NT event log under application. You would use this because if your component was running on a server in the inet info process and it threw up a message box or attempted to, in fact that message box would not appear, but it would hang that thread. And consequently any clients using that thread would also hang in their browser. With unattended execution, it's logged, the thread can continue, other objects on that thread can continue. Mark as apartment threaded because, well, the alternative is to have your component be single-threaded. If it's single-threaded, then of course all the concurrent requests from the clients have to be marshaled over and queued onto these objects on a single thread. They have to be queued up and performed one at a time. With apartment threaded, the objects can deal with requests concurrently. I recommend setting binary compatibility for your components because of several reasons. First of all, if your component is part of an enterprise system of DLLs and they all reference each other, they're going to be early bound to each other. If you make a bug fix in one component, you want to be able to recompile and not have to recompile the other components. So you would set binary compatibility. That would mean you don't have to recompile the other components. This will lock down the type-lib GUID, the co-class GUIDs. The interface GUIDs will stay the same, providing no new functions were added to the interface or changes to the function signature took place. If I can go on a slight tangent, an alternative to binary compatibility that's very useful for Visual Basic developers is to actually centralize the interfaces into an abstract type-lib. Here you use an IDL script and then compile with middle into a type-lib. And then with the Visual Basic components, and there may be a lot of them, I've seen some enterprise systems with 50 DLLs or whatever, can then all reference this abstract pipeline. They won't need to reference each other. This locks the interface goods because you're in fact allowed to change, you're allowed to remove functions from interfaces or change function signatures, etc. And Middle won't complain when you recompile. It'll keep the same GUID. That's useful for Visual Basic developers. It's a clean architecture because the abstract interfaces are kept in one place and then the concrete classes are implemented in another. It avoids various circular reference problems because now the components can still be early bound. They only need to reference the type life and use create object to instantiate each other. Some performance improvements in Visual Basic 6.0. In Visual Basic 5.0, the project state information for a project was kept as a global. And when objects on different threads needed to get at this project state information, they had to obtain a lock, read the data, and then release the lock. Of course, this caused various thread contention issues and proved to be a performance hit. In Visual Basic 6.0, they cache the project state on a per-thread basis. So I'm told that the only locks that take place occur when the object is instantiated and the system heap is used to allocate out memory for the object. Retained in memory is another new feature in Visual Basic 6.0. In Visual Basic 5, for a server component, when the last reference to an object was released, Visual Basic 5.0 runtime aggressively unloaded the runtime, unloaded the project state information, etc. This is a disaster when you have a client that logs on and he perhaps uses the last object on a thread on the server, he logs off, a new client immediately comes on, there's this tear down and load up. Retained in memory will mean that the runtime will stay loaded, the project state information will stay cached on the thread. Some unofficial performance numbers were that for an ASP page that did a create object on a Visual Basic component, and then instantiate, invoke the method that did nothing, and then set the reference to nothing, that ASP page could be hit about 140 times per minute with a Visual Basic 5.0 component. When the component was recompiled in VB6 with retained in memory set, that went up from 140 to 270 requests per minute, so a substantial improvement there. So going into debugging Microsoft Transaction Server objects, in Visual Basic 5.0, it was quite a bad story because unfortunately getObjectContext, when you were debugging in the Visual Basic IDE, the getObjectContext would return nothing. Consequently, you would get a runtime error whenever you called getObjectContext.setComplete or setAbort. They changed that story slightly by allowing you to tweak a registry key so that getObjectContext would return a valid object, but the object didn't do anything when you invoke setComplete or setAbort. In Visual Basic 6.0, they've improved the story considerably. You are able to debug the object in an MTS transaction context. It will behave the same way it does in the runtime environment. The only caveats are that the NT4 SP4 must be installed, and the MTS transaction attribute, the class attribute that I've shown, has to be set away from the default of 0 to some other value. So let's debug the online stock application. Presently have $20,000 in cash, so I'm going to buy another 100 Microsoft shares. That will reduce the cash level to 10,000 and increment the number of stocks held. We come into the debugger, get hold of the database connection. Notice this class has no members and uses no globals. I'm trying to be a well-behaved stateless object here. Check that the customer has enough money. You then go into the routine to debit from one SQL Server database the amount of cash held, and we're going to update to $10,000. That part goes well. And then I update the number of shares held to 210. Going back, we see that that has happened correctly. Now let's look at the case where we do a set abort. I'm going to buy 50 more shares here to reduce cash to $5,000. Again, the transaction has been started automatically before the method has been entered. Go into the routine to buy the cash, actually debit from the cash. Yep, 5,000 is what it's set to. We've updated that database. Now at this point, if I set the next statement into the error handler down into set abort, we're going to tell MTS to abort the transaction. As soon as we exit the method, it should in fact roll back. So hopefully our cache is still set at 10,000, and that has occurred. So set complete and set abort work the same way as they do in the runtime environment, which is a new feature for Visual Basic 6. Debugging caveats in Visual Basic IDE, well, there's still a few, unfortunately. You want to avoid code in the class initialize or the class terminate event. The transaction context has not been set up by the time those events are called in anyway, and that's true at runtime as well. Components run in the IDE run as a library package. They run as part of the Visual Basic process. Remember, security is only supported when components run as part of a server package. So consequently, you won't be able to debug any security logic that you have in your components. The Visual Basic IDE is single-threaded, so you're not going to be able to debug any thread contention issues or concurrency issues that occur. If you need those kinds of features, you can use the Visual C++ debugger to debug the Visual Basic component. You compile the component with symbolic info, with native with symbolic info, which will put out a PDB file. You open the DLL as a workspace, open your Visual Basic source as per usual and set breakpoints. You set the launching application to be mtx.exe. This is the MTS process that wraps around the component and takes care of the transactions, etc. You set the command line switch to be /p:, and then the name of the package that holds the component or the GUID of the package, which is shown in MTS Explorer. Let me just try and demo that. Here I've got a component in Visual C++. I've opened up the DLL. In Visual Basic, I should say, all I did was compile with symbolic info, which is in the options. Right here, I would have checked this box. Going into Visual C++, the settings, debug tab, I've set the executable that's going to wrap around this DLL to be mtx.exe in the Windows system directory, and then /p:, and then the name of the package that holds the component. In this case, here's the package. I could use the package GUID, which is in the properties window right here. So let me set that into run mode. Here we go. mtx.exe needs to get launched. Wait for it to be launched. Now this is an administration routine which just adds a new equity to be sold. In this case, I'm going to add Intel. Accept. Here we go. And let me open up my rich Windows client application for this. 3 lines of code. Then we call into, from the Visual Basic IDE, hopefully into the Visual C++ debugger. Here we go. I get the database connection. Notice that's taking a long time. I'm guessing that the pool was flushed out in the interim. It shows the importance actually of a connection pool. Here we go. And then we can step through F10, F10. Of course, this is in our object context as well, so it behaves the same way as it does in the runtime environment. This time, though, I get the thread information, etc., so I could debug any concurrency issues, etc. So using the Visual C++ debugger, the thread information is available. We're able to attach processes. We can debug a component that's running as part of a server package, unlike Visual Basic, which can only debug the components running as part of a library package. We can debug into the INET-info process and discover concurrency issues or thread contention issues that might be happening. So the call to action for this talk, 3-tier for scalable applications, but just being 3-tier isn't enough. You have to design the objects to be stateless, at least as much as possible. Perhaps, if it is stateful, try and use the activate and deactivate events to release the limited server resources when possible. Leverage the Microsoft Transaction Services, which include transactions, just-in-time activation, the object pooling for database connections anyway, and then there'll be future services such as in-memory databases, object pooling for your regular Visual Basic objects, etc. in COM+. Use the Visual Basic 6.0 debugger to sort out the programmatic logic in your components and debug the general logic, and then the Visual C++ debugger for thread contention issues or other things that may arise that the VB debugger can't handle. Got some useful references here. I do recommend the Professional MTS by Rox Press. All the material in this presentation is also in that book. I definitely recommend looking at the README that ships with Visual Basic 6.0. This has the caveats on debugging the MTS components, as a useful knowledge base article from product support on debugging a native code component generated from Visual Basic. That's all I have. I'm conscious of the fact that I've ended a little early, but are there any questions at this point? I'll try and answer. Oh, yeah. So you can't seem to watch objects in the Visual Basic debugger or the Visual C++ debugger? I think you can watch objects. So the question was, can you watch objects in the Visual C++ debugger when you're debugging a Visual Basic component? You can't seem to do it very well. I think you're able to watch objects or at least see values. What you're not able to do, and I should have mentioned this, is the edit and continue side of debugging. You can't make a change to your code and then just carry on in the debugger while it's in run mode. That's really cool in Visual Basic, but you can't do that in Visual C++. Yes.